Hello and welcome to the next tutorial. So this time we are going to be taking a look at making jump pads. So in particular what we're after here is something where we've got a good range of control over how that jumping happens. So we want to have the option for having a bit of a delay there and being able to control that. We want to be able to control sort of when a character jumps on it, whether it's something that is only just exerting a force in a particular direction or being able to actually merge and blend in part of the player's already existing motion. So that then players can do something where, if you land on a jump pad from a higher height, that actually increases the sort of force that you get launched with, and being able to hit a jump pad on an angle, that actually has an effect. So we want to set up so we've got a bunch of things like that supported for this. So let's dive on in. So starting point for this is I just have my first person control of the template level here, so I can run around, and we've got basic ability to be jumping, to be heading up slopes, things like that. So we're going to get our jump pad set up. We're going to try and have this fairly self-contained. Now this is going to be going via the physics system, which has couple of advantages and a couple of things that to watch out for that will result in hilarity. So things for it to be able to physics them, those things are going to need to have a rigid body. That's going to be an essential thing. They must have a rigid body for us to be able to actually move them. So I'm going to set this up to work with my rigid body based character controller. Now it is quite possible that if you're setting this up to work with another rigid body controller, that you might need to make modifications to it. So there might need to be stuff where you actually turn it off of its sort of normal control. Is a possible thing. So it's just something to be aware of. And there will be a modification that I need to actually make to my character controller because it wasn't originally designed for supporting jump pads. So there is a change I have to make to it. So let's get set up, get this nice and self-contained, and what I'm going to do is, the goal is essentially all of the logic is contained in the one script. So we'll have our jump pad script, and what we want to be able to do is essentially apply this onto something in the world. So I'm going to set up a cube. This is going to be the jump pad frame. And then I'm going to also then have another one that I'll attach under it. And this is going to be the jump pad itself. So we'll have this idea of it as a frame, and then we have its actual sort of surrounding setup. So we'll set up some materials for this as well, just so we can have this looking so it's something that stands out, because we do want to make sure that it's very visible what this is. So we'll set up our two materials, jump pad frame, and that'll apply to the frame. And then we'll have the actual jump pad itself. Jump pad. Which what I'm going to do is the frame, to make that sort of stand out, I'm going to make it that the jump pad itself, we'll make that a bright sort of bluish green, and the frame will make that jet black. So our jump pad and jump pad frame, we can move these over here. So the jump pad frame itself, I'm going to get rid of its collider because it's going to be a fairly small sort of area. I don't really want it to actually have a collider there on it. So we want this to be a bit narrower, a bit sort of shorter in height. We don't want it to be that current height. We also want to make this a little bit larger in size as well. We want to make sure it's something that, especially when we're testing, we can easily position, line up, and be able to appropriately stand on it. So in the actual jump pad itself, We'll shrink that a little bit because we want that to stand out from the rest of the surface here. So probably like 0.95 will probably do pretty good. And then we'll just move that up the tiniest amount. So that gives us our jump pad. So the idea is we'll be able to step on that and then that will launch us. So I'm going to put our script on this. And what I'm going to do to start with, just as something that we want to have as an easy way to be testing this, because I want the jump pads to support any object. So any object at all, I want it to be able to be affected by the jump pad. Because that gives us a thing where we can then throw something and bounce it off of the jump pad. So let's start that like 3 meters up. 3 meters up, and we'll give it a rigid body. So that looks good. And we'll just rotate the player around so that they can see all of this to begin with. And move them back a little bit. So we'll get it working with the cube first, and then we'll go from there. Now, this is something where these things that are interacting with this are going to be moving fairly quickly, and potentially their speed will be going up quite a bit. So it's something where what we may end up needing to do is, if we take a look at the cube, for when we set up the rigid body, we have these collision detection options. And these collision detection options are something that you may need to change if you have something that is moving quickly. So in general, how these work, discrete is checking for collisions at the particular update rates, whereas something like continuous, those ones actually do, so not checking in between the frames, but when it goes and does an update, it checks sort of that path that the object would have taken. So continuous is going to be a little bit more intensive. Things like continuous dynamic are designed for quite rapidly moving objects. So continuous dynamic is going to be more expensive again. So you wouldn't want to have everything in your world like that. It's something that you want to be fairly selective about which things you use that for. But what to look for is if you've got cases where collisions are being missed, things are going through objects, that's where you probably need to change that collision detection mode there. But, so we've got a jump pad. This is our initial case we want to be able to handle. The other stuff we're going to want to be able to do is be able to handle things like, well, if the jump pad's on an angle, stuff like that. But those are going to be quite straightforward things for us to be able to handle. Now, with having the jump pad script on here, this is going to mean that collision events, we won't necessarily receive them. So we'll write the code, and we're generally, and this is an easy thing you can run into, that you don't get collision events coming through properly. Because it does depend upon what's impacting what and where that event gets called. So one of the core things I'm going to need to be able to do is on collision enter and an on collision exit, because I want to know when something has left contact with the jump pad. And just for now, I'm just going to do a debug log and log out the game object name. Because what we will expect to find, generally what I would expect to happen in this scenario is we won't actually get the event because the thing that's being intersected with is the child, and so as we saw, we didn't get that event. So there's different ways we can go about handling this. One of the options that we could certainly do is we could move that collider up to the actual jump pad script here. Then we would be able to get that event. So if I added the collider in and then resized it, we'll see that that will appropriately come through. But that does then mean what I need to do is adjust this collider to match that child one. So we need to change, that stays as 1.95, but that goes to 0.1. So we can see where everything is located. What that would mean is we turn the collider off on this one. So now the jump pad frame has its collider, and if need be, we can edit and we can see that that's definitely lined up. So now when we run it, cube drops down, we get the event. So cool. So we've got the first part of it with it detecting the collisions, which is great. Now we need to actually start looking at how we go about launching this. So to launch something, we need to have a rigid body. So we also potentially want to have a delay, which means we can't necessarily launch it at this point. So we need a way of keeping track of these targets. So this is something where what I would do is I'm going to actually set up a struct. Doesn't need to be public because we're not using it anywhere else, and it can actually go inside the class here. So jump pad target. So it's going to store the contact time because one of the settings I want to have is a launch delay. So launch delay. So essentially how long after hitting before it will actually launch the particular object up. So we'll have our launch delay. So that means I need to be tracking the contact time. So when it actually made contact with the jump pad, so I can see, okay, is it time for this to be launched now? So contact time, so that I will need to know. There'll be other things I add in as well, which we'll get to those, but for now we want to be able to do that. I also then need to be keeping track of stuff like the rigid body, things like that. I potentially want to be able to really quickly and easily remove those. So what I'm actually going to use is this is a case where I would use a dictionary, where the key is the rigid body and the value is the jump pad target structure. So targets, and we can just set that up. So that's good. That will give us our tracking of the targets. So when we have collision enter, we need to first get the game object in terms of we need to try and get the rigid body that's on that. So what we can do is we can say, okay, well, collision, game object. And this is a good case for using a try-get component because a try-get component won't do any allocations if it fails. So it's a bit more robust and reliable. It's a little bit better, not more reliable, but it's a little bit faster there. We're not wasting allocations. RB, so F, and then we have out RB. So we're attempting to retrieve the rigid body. So if we retrieved it, then what we do is we immediately add it into that targets list because we've had that collision, so we know we can add that as a track target. So we would go targets RB is equal to, and then we can create a new jump pad target, and we can initialize. So contact time can be time. And we can go for time since level load. So, okay, we've added the target in. That's great. Now we need to then, after that delay, launch it. Now we don't want to do that in update because we are working with stuff that is physics related. So that means what we want to do is have a fixed update. And then in fixed update, we want to go through any of those targets that we might have. So check for targets to launch. So we can loop over key value pairs in targets. Now the key is going to be the rigid body. The value is that structure that has that time. So we need to be able to launch anything that made contact more than launch delay ago. So we could set up here threshold time is our time, and our time since level load minus launch delay. So anything that is earlier than that time, we can launch. So we would then go, okay, well, if KVP value contact time is greater than or equal to that, then we're going to say, well, launch, and we give it the key. So we're telling it the particular thing to launch. So I'm going to set that up here. Launch, rigid body, target RB. So, okay, we've got the ability to launch it. That's great. When we launch something, we then want to make sure it's removed from our set of targets. We don't want to be risking potentially launching something multiple times. There could be a little bit of a delay before it breaks contact, potentially. So what I would want to do is I want to remove that target. But I can't remove it just yet, because this is something where I would, if I removed it while I'm looping over it, that's actually invalid. That will invalidate the collection and I'll get errors. So I need to keep track of the things to remove. So what I would be doing is something like this. I would have a list, rigid body, and this is targets to clear. So targets to clear. Now I don't want to be allocating this every single fixed update. That's not good. So what I'll actually do is set this up here so that I'm not recreating it. And what I do is here I go targets to clear, add KVP key. So that's good. And then down here, I loop through all of those ones to clear for target in targets to clear. And all I do is I can then say, well, targets, remove target. And then at the end of that, I can go targets to clear dot clear. So I don't want to set it to null because I don't want to destroy it. I'm just making sure that I'm minimizing the amount of sort of memory allocations there if I can. So clear out. So that looks good. So then for launching it, okay, well, there's a few things that I need to know. I need to know the direction to launch it in. I need to know the force to launch it with as well, because that's something where there's a lot of sort of potential stuff there in terms of how much force I want to be applying. So I want to be able to say launch force, and let's start that at 100. And because we might need to, we're going to make it that we can control that force mode. Because we have a bunch of different force modes. We have some ones that take into account mass and some that don't. We have some that are instantaneous and some that are continuous ones. So what I'm going to use for this is I do want it to take into account mass. So we're going to go with then, we're either looking at force or we're looking at impulse. So one's an instant, one's a continuous one. I'm going to go with impulse for this. So that's good. So, okay, let's get that up and running then. Because we've got the rigid body, it's pretty straightforward for actually adding this in. So what I would do is target rigid body, add force, and then, well, the jump pad, it's up direction. I could use that. So I could say, well, transform.up times by launch force, and we have launch mode. So let's test this out. Let's see what happens What we're expecting to see is the cube lands and ideally bounces. We might need to adjust the launch force there. We'll find out. So we can see it hits. So we definitely need to adjust the launch force because that cube is very far away and still going because it got launched. Now it's landing back down. So, okay, we are going to lower that force quite a bit. So we'll take that force, we'll drop it to 10. It's going to be a little bit more reasonable. So that's good. That's, sort of the behavior we want there. So it's able to be bouncing, things like of that, it's still rotating, which is cool. So that's good. I'm going to turn that cube off, and let's see what happens if just I walk over it. So I'm here, I walk over it, and it does give the player character a little bit of a hop. But what I'll notice is if I jump on this, it doesn't. And so it's not sort of managing to continually provide a boost there. And as I said, that is something where there are some small changes you might need to make to different or potentially larger changes to your actual character controllers. So in my case, one of the ones that I know that I need to actually make is, so the character controller does have a setup in it where it will go to sleep essentially. If it's not jumping, if we're on the ground and the velocity is below a certain amount, it actually forces it to sleep. Not really necessary, it's a little bit of overkill, and that actually does cause issues. So I'm actually going to turn that off. And then we'll see, with that turned off, we can wander over. And so I wander over. And as should happen, it's actually bouncing me multiple times, which is good. Always the same height though. And this is where what I would like to do is start to have this, that it's taking into account the actual impact force there. So how strongly we've impacted on the jump pad and then being able to combine that. The idea being, if you get up to a really high height and land on the jump pad, that sends you going higher. And that's what I want to be able to achieve. So we can do that because what we can do is when we collide, we can actually get the relative velocity of that collision. So what I'm going to do is have this here. So we can have public vector 3 contact velocity. So there's two things we could potentially grab. We could try and grab the rigid body's velocity, or we could actually grab the relative velocity. So let's take a look at what those actually are. So RB velocity, and we can just log that out. So RB velocity, or impact, and then we can go for collision relative velocity. So we want to see what we actually get with these two ones here. How different are these? So let's enable the cube again and let it impact. And just so it's able to bounce up and down continually, I'm going to freeze rotation on it. Wouldn't normally do that, but in this case it just makes testing a little bit easier. So we can see it impacts, but our rigid body velocity is always 0, which makes sense because it's collided. So that relative velocity is what we want. That's going to be the relative velocity at impact of the two objects. So what we can do is then we can check the name. So we have contact velocity, and that is going to be collision relative velocity. So, okay, we've got that relative velocity. Then it's a question of what do we do with that? Because we've got that, we want that to be able to scale up the impact there. And what we can do is we can take a look and see how much of the impact is essentially perpendicular to the surface is a good way of doing this. So what we can do is we can, and what I'll start doing is we'll have my launch vector starts as transform.up, but then we're going to start adjusting that. So first thing I want to do is project the relative velocity along the jump axis. Because if we take a look at what the velocities were, so these were downwards, so they were into the particular object, which is good. So we would say, and we need then our velocity being passed through. So what I'm going to do is pass in through here when we do the launch, AVP value, contact velocity. We set that up here as well. Contact velocity. So we say contact velocity, and we do a vector 3 dot dot with contact velocity and transform dot up. What this will do is this will give us the component of that contact velocity along our jump axis. So that projects it along it. A dot product gives you the projection. So contact projection. So, okay, that's going to be, in the case of this one here, what we would get is minus 6.87 for the first one, minus 9.82 for the second and third ones. So the larger that is, then the higher that component is. So what we could do then is have this be able to vary that launch vector. So it's going to be able to scale it up or down. And so that means we want to be able to have it increase or decrease the force. The idea being that if you were really, we only need to support the increase, but we could allow it to do decreases as well. But if we went for just the increase, then the larger, the more negative that value is, the more we increase the force. So firstly, if contact projection is less than 0, that means we're increasing the force. So we want to have a mapping of how much we increase that by. So what I would be able to do is I could do something, there's lots of different ways, but essentially I need something that takes that value, like that minus 9.8, and scales it. So it could be something where we just do a fixed multiplier by that. But we want to have a cap to that, because if we allow it to scale up too much, you could get to the case where it's very easy to have it that the thing is launching you out of the environment. So impact velocity scale. So we want to allow it to be able to scaling things up, but I want to reduce the amount quite significantly. And I mean really quite significantly. So whatever the velocity was, I'm going to start at something like 0.05. So that would mean like if that minus 9.8, so one's like minus 10, it's actually only going to contribute a 0.5, so a 50% increase, which even that is quite high. So we potentially need to lower that even further. But velocity scale, and then we'll have a cap. So max impact velocity scale. So we limit how much it can increase the velocity by. So this is essentially how much of a boost you can get at most, because we do want to cap that. So I'm going to say 2. And then what we would do down here is contact projection times by impact velocity scale. We do need to do the absolute value because we don't want that to be negative. Then it's the multiplier is going to be 1 plus that. The idea being that the higher that impact velocity is, the more it's going to increase it. But then we need to be able to cap that. So we can do a mathf min of our max impact velocity scale on this. So this gives us now our overall velocity scale. And then we do launch vector multiplied by that. So scale up the launch vector based on how fast we hit. What that will mean is our cube will bounce, and each progressive bounce, we're expecting it to get higher because it's going to have more force being applied to it. So it will drop, goes up to about 9.5, goes up higher again, and so it will hit a cap because we've got that max scale. So it's still able to be building up a little bit, but we can see that it is starting to really cap out, which is good. That's what we wanted, that it has a limit of how much it's able to actually scale up and how much it's able to be being sort of accentuated by the existing movement. So that's good. Let's see what happens with then the player. So player, they do move a bit more, but the player is something where, because the player is a rigid body that has some active control on it, that's actually pulling it down when they're up in the air, the player is going to not get knocked around quite as much. So if the jump pad is making contact with the player, that is going to need a little bit more force than what it actually is applying. So if I change that launch force to more like probably 50, might be a little bit overboard, but we'll see. But this should allow me to, and we can see player is moving a bit higher again each time. But yes, the player will not go as high because the player has the extra stuff sort of more actively pulling them down, and that's because the player has a very specific feel for the jumps that are trying to be conveyed. So again, that's something you will run into, that if you're dealing with these with a character controller, they are going to behave a little bit differently. And you might actually need your jump pads to be aware and specifically check, am I talking to a player or am I talking to something else? Now the player, we do have everything for the player is tagged. So we could actually quite easily check if this is the player and adjust the force. So that's something where we found that a multiplier of about 5 worked pretty well. So what I could do is set up player launch force multiplier is 5. Idea being that this is then something that is going to work for players and other objects quite easily. So we could check if target RB, compare tag to player, then we'll use launch force multiplied by that. We could also actually just do launch vector multiplied by that. Allows us to keep that line the same. So now we have this working for both the player, for those objects. So good so far. Now I want to be able to do something a little bit more ridiculous though. What I want to be able to do is, well, firstly, I am going to prefab this jump pad. So we'll create a folder, set up the prefabs, but I want to be able to make a really long jump pad. Because what I want to be able to do, jump pad long, I'm going to unpack this prefab because this will be a significantly longer one. So the idea is going to be, I'm going to move this over to here. And I want this to be, as I said, really, really long. Probably like 20, maybe 30. That's pretty good. So the idea is this is something where I want to be able to jump onto this and then bounce the entire way along. So the jump pad mesh there is going to need some tweaks. Looks about right. 995. Does mean we need to make sure we update the collider for this as well. So what I want to be able to do is run, jump onto this, and bounce the entire way along. That's the goal. So let's test and see what happens at the moment, because we haven't coded anything specifically for this. So what happens right now, if I run and jump, you can see I'm just jumping on the spot. It's not carrying forward any of my existing movement. But I actually have my existing movement information. I've already got that. So I can actually blend that in. So we want to, again, be able to control the amount of that gets brought in. But we have that contact velocity. So I know how quickly and the direction I was moving at the point where I launched. Because if I turn off the cube, and if I put back in the debug log for the contact velocity, and we take a look, we'll see we have a bit of extra. It's not just the vertical component. If I actually run and jump onto this. So set up, run. So you can see there is, because this is along X, there was an X component there for it, which is great. So I can actually blend that in. So what I want to do is I need to be able to distort that. So I'm going to have a distortion vector. It starts out as the contact velocity, but I want to get rid of components that are not the transform up, essentially. So I want to be able to remove anything that is not fully in that plane of the particular movement there. So what that means is a couple of things. I can reconstruct this using a couple of interesting little tricks, because we saw the style of what the distortion vector was. So if I do a vector3 ... contact velocity with my transform dot forward. So I can do transform dot forward plus multiplied by that. So that gives me the component of the impact on the forward plus a transform dot right. So I've done everything apart from transform dot up. So let's log out that, because we know what the previous one was. It was primarily negative in X. There was a tiny amount in Z because I wasn't perfectly aligned with it, but it was primarily movement in X. So we take this, I run, we can see we've got those components there, which is great. So, okay, we've got our distortion vector. Now, the reason I didn't just go and zero out the Y component was because our jump pads could be on an angle. So we calculate the distortion vector. Now, similar to the setup with the contact velocity, we want to actually control how much of this gets blended in. So we can have a serialized field float max distortion contribution. So this is going to be the maximum amount of it that it's able to actually control. So maybe max distortion weight is going to be a better term for it. So we don't want to have that be able to necessarily go too high. This is going to control essentially how much we can sort of bounce along the particular one. So 0.25. We could also have a scale for that distortion as well. What I'm going to do that we'll try out first is we're just going to go for normalizing that, seeing how that looks. Because what we could do is launch vector plus our distortion weight times by distortion vector normalized, and then we renormalize all of that. So this is going to do two things. It's going to lessen the impact of really large values, but accentuate the value of the impact of small values. So it may not quite work exactly how we would like. So we're going to just test and see. Okay, so let's test this out. So if we run this, and what I'm going to do is I'm going to pretty much just run and jump and stop. So I do that, and we notice we move, and when we're looking at the logs of the output there, it's applying a launch force, but that launch force is very quickly going to 0. And there's a reason for that. So when I jumped on the pad there, I actually released the keys. If I do this again, but I jump on it and I hold the keys down, we'll notice I keep moving. And the reason for that is if we take a look at the character motor, one of the options in the character motor that I added in was this idea of air control. So in the character motor, if we take a look here, it's got stuff for if it's grounded, it's got stuff for if we've got air control, and air control directly overrides the velocity. And in particular, it's using a movement blend rate, the idea being that there's a bit of a mix there. So that's something that we do need to watch out for. And again, when you're working with a rigid body controller, if it's one that's off the shelf, you need to check stuff like that. So I'm going to turn off in-air control, and I'm again going to up the distortion weight. So then we'll have nothing that'll be sort of overriding the velocity there. So I'm going to run, I'm going to jump, and we can see we're able to hop all the way along. So that's cool. What about if this is on an angle? Because that's one of the things we haven't yet tested. Okay, well, what if I put a jump pad on an angle? So I'm going to put one here. The idea being I can run up the ramp and then I can jump on this. So let's rotate this. I think like -30 is probably good. And let's move this so that it's here. So what I'll do is I will essentially walk up the ramp and onto the jump pad. And what I'm expecting is that I get launched. That's what should happen with that. So I'm up here, up onto it, and it does launch me up and over. And I could have multiple ones there. So if I wanted to take this long jump pad and rotate this 90 degrees like that and move it to here, then what I can do is I wander in, head up the ramp, head over onto this, and then I go bouncing along and off the edge. So we've got our jump pads. We can position them where we need in the world. We can control the sort of weight of things like the contributions of your existing motion. We can control the scaling up that the player gets. We can control whether it's taking into account the mass of the object or not. So heavier things, with what we've set up, heavier things will not move as far, which is cool. It'll work with generally any object that's a rigid body. So dive on in and see the kinds of cool things you could make with this. You could set up sequence of obstacles where people are jumping and bouncing from area to area. Ones where you have to drop something on one jump pad and that's going to then launch it to others, or ones where you have to get up to a certain height to interact with them so that you can go flying far enough. Lots of different things that you can be setting up there with this. Thanks folks, I hope you found the video helpful. If you're looking for the code for the project, then that code is available up on GitHub. You're free to use any of the code in any of your own projects, commercial or non-commercial ones. And if you've got questions on the project, chuck in a comment below. Or if you want to submit them for another Q&A video, the link for that's in the description as well. If you have found the video helpful, please chuck in a like and subscribe. It's something that really helps out. It's very much appreciated. And if you're looking for other ways to support the channel, then I do have a Patreon, and the link to that's in the description below as well. But until next time, bye.